Alright, this is 9.6 part 2, and we're going to go ahead and start off with the definition of combinations. So it's a subset of permutations, and it's when order does not matter. For example, choosing a team of 15 people, the order does not matter because if we were to shuffle those, we would still have the same 15 people on the team. Alright, so example number 1 says, in how many different ways can 3 letters be chosen from the letters A, B, C, D, E? So there's really no easy way to do this, but I just kind of think, okay, I could put A, B, and C together. Then I'm going to do A, B, D. Then I'll do A, B, E. And then what I do is I move on to A, C now. So A, C, and B I already have. That's my first one. So maybe A, B, A, C, D. Then I could have A, C, E. I don't have that one yet. Okay, so then I could move on to A, D. So A, D, B, I already have that one. That's my second one here. A, D, E. Nope, I don't have that one. So A, D, E. Okay, so now I already did A with all the letters. So I'm going to move on to B and C together. So B, C, and D. I don't have that one. So B, C, and D together. Okay, B, C, and E together. Nope, don't have that one. Okay, now moving on to C and D together. So C and D and A are already together. The fourth one right here. Then C and D and B are right here. And then C and D and E, C, D, E. We don't have that one together. Okay, so now we're moving on to D and E. Okay, so D and E and A is the first one on this second row. D, E, and C, that's this one right above. D, E, B. So D, E, B. Nope, I don't have that one. So that's my last one. Because so I would have 10 different ways. Alright, so another way to do the previous example is to instead use a formula. The number of combinations of n elements taken r at a time is n choose r, which is n factorial, over n minus r factorial times r factorial. In other words, we could write it as n permutation r over r factorial. So you could either learn that one or that one. Either one would be correct. And so the next example that we're going to do is a standard poker hand consists of 5 cards dealt from a deck of 52. How many different poker hands are possible? So we have 52 cards and we are choosing 5 cards, and so this is what the standard deck of cards looks like. So, and because if we shuffle those cards in our hands, the order doesn't matter, so it's a combination. So this would be 52 choose 5. So it's going to be 52 factorial over 52 minus 5, which is going to be 47, and then times 5 factorial. Okay, so from the previous example, we know, or from the previous lesson, we know we're going to try to cancel these out. So we're going to go ahead and write this out as 52 times 51 times 50 times 49 times 48 times 47 factorial, and then times 47 factorial times 5 times 4, 3, 2, and 1. So this 47 factorial is going to cancel out with the 47 on the bottom. Then I know 50 and 5, that's going to be 10. And then I could do 10 and 2, that's going to be 5. And then I could do, then I'll just multiply the rest of this out in my calculator and divide by the bottom. And I'm going to get 2,598,960 different poker hands. And again, I just want to, you can do 52, choose 5 in calculator, and I could attach a video for that before your next quiz. Alright, this last one, so you are forming a 12-member swim team from 10 girls and 15 boys. The team must consist of 5 girls and 7 boys. How many different teams are possible? So in this case, this is the fundamental counting principle, because you're going to multiply the ways to get girls and then the ways to add boys. And so for the girls, it's going to be 10 combination 5, and then we're going to multiply that by 15 combination 7. So in this case, you could go ahead and multiply this out and you would get 252. Multiply that by 6435, and then multiply those two numbers and we get 1,621,620 different possible teams.